Can you see this? Can you see this page? Okay. So you see, the first thing is that you have to, well, just a minute. Just a minute. Okay, first the thing is that you have to create your Moodle account, right? So do you know how to create Moodle? I think already. Okay, you have done it in the previous, I guess, data structure class or some other classes. Okay, so I'll be creating this course name CSC 403. Okay, so this is design and analysis of algorithms, right? Design and analysis of algorithms. So this is the course name, right? Design and analysis of algorithms. And not audible. Okay, now I am audible. Okay, so first I will be creating one link for Moodle for this course, CSC 403 Design and Analysis of Algorithms, right? So this course I'll be creating, and by this week all of you join in this course. Okay, so that whatever assignments I'll be posting, you can see, and I'll be posting the videos whatever I am recording. Okay, so everything will be there. If I am not audible at any instant of time, you just remind me. Okay, so this is the mandatory thing. This is mandatory for you, and you know how to join in this Moodle. Okay, so this course I'll be creating today or tomorrow, and then from tomorrow onwards you can join with this course, right? Okay, so this is the first thing I had to mention for this course. And another thing is that, okay, you should be, if the class is from 2:15 and you should be trying to join by 2:15 or by 2:17, not more than that. 2 minutes I can give. By that time I'll start. Okay, so 2 minutes you can get from the scheduled time, right? 2:15. Okay, so this is the thing. If it is from 3 o'clock, right? It is from 3 o'clock, then you have to join by maybe by 2 minutes beyond that. Okay, so first this is the syllabus actually. So I'll be posting that syllabus in this course in the Moodle. Okay, so first the first thing that you have to know that why we are studying this. Why? So what is the course outcome? Course outcome of this CSC 403 Design and Analysis of Algorithms. So the first thing that is written here is this Students will be able to define many important concepts such as asymptotic analysis, dynamic programming, recurrences, etc. You see, this is a mandatory verdict that we'll be discussing this thing in the introductory class, right? And so that when the NBA team is coming, so that you can at least know these are the terminologies they will be asking, whether course outcome is uttered in the class or not. Okay, so these are the important concepts that you have to learn, and we'll be discussing all these concepts. Definitely, students will be able to describe the key ideas of different algorithm design paradigms. There are many paradigms, such as one is this dynamic programming, one is this divide and conquer, one is this greedy algorithms, one is this reduction. Okay, there are many paradigms. That means the techniques with which we can design, we can proceed for designing algorithms. And this the third is maybe this can apply different algorithmic ideas efficiently to solve new problems. So right now I'll be giving you some of the glimpses of modern algorithms, modern problems where algorithms are being used. So whenever a new problem is arising, okay, there are lots of problems due to the internet, due to this online nature of the online nature of everything. Newer and newer problems are coming for these algorithms to solve. That means we have to design algorithms for this. Students can analyze and understand the time complexity of algorithms and its correctness. So algorithms complexity and correctness, you have to also know whether one algorithm is correct or not. Can evaluate the hardness of the algorithm if required. So this will be the last thing that we will be discussing, whether this is actually the real computer science begins with this hardness of an algorithm. Real computer science, okay, the science will be beginning with that term, hardness of an algorithm. And by far this is one of the most important subject of whole of the subjects you will be taught in your CS course. Okay, so this everything, the present world is shaping around this term algorithms. Okay, so everything is under the lens of algorithms. So that's why this algorithm is very important to know. All the nitty-gritties of algorithms, all the techniques with which we will be proceeding for designing algorithms. Okay, so as you are seeing that introduction and basic concepts, we'll be having these asymptotic notations and then these recurrences. Okay, that means the divide and conquer. So this lower bound amortized complexity analysis using induction to design algorithms, divide and conquer, this greedy algorithm, then dynamic programming is there. Okay, so dynamic programming is there as well. So this, you see, this dynamic programming is also there. So now this now a little bit say this why say take one problem. Okay, take one problem. This is a very important problem, and whenever say you are joined in Google or Microsoft or Amazon, okay, they might be asking that this problem whether you know or not. Okay. So the problem is this thing, that say these are some advertisers. Okay, these are some advertisers, and then one user is there. Okay. One user is there, and these advertisers are fixed. These advertisers are fixed. Advertisers. So these advertisers are fixed. These are advertisers and they are fixed. That means we know who are the advertisers. Who are the advertisers? A priori. Before doing the algorithm. Before doing the algorithm, we know. Before doing anything on that algorithm. But this side, you see this side, the users. Users means you. So whenever you see this, whenever you are searching something in Google, so this bar is there and say you are searching for, say, Canon. So this camera you are searching for, right? And then some page links will be coming. Some page links will be coming, right? And along with this page, so you have seen that some of the advertisements which appear this side, maybe on top as well recently. So this is the ads. Okay, this is the ads, right? So there are lots of algorithms which lots of algorithms for designing ad placements in Google, Microsoft, Amazon, Facebook. Okay, so whenever say you are doing some kind of Facebook, then some specific ads are shown to you, right? Some specific ads. So this is one real life problem, right, where these algorithms are being employed. So there are multiple layers of algorithms which are there for this. Maybe the first thing is that whenever you are appearing as a search, right, Canon, whenever you are doing, so which are the ads to be placed here? Which are the ads to be placed here, right? When you with the age group, say 18 to 22, in this age group somebody is coming, then which of the advertisers will be targeting these users? Okay, so that is the problem. And the thing is that this user, you are coming right now, this user, one user will be coming, and then another user will be coming, then another user will be coming. So this is an online algorithm. That means the users are coming in an online fashion, dynamical. That means they are not fixed. That Google is not knowing who is the user who will be coming next. Okay, right? So this is, and you see that if this is the problem, and say this user is being targeted by, say, this, all the advertisers already have said Google that if anybody is coming with this search and with this age group, then I am there for the ads. Okay, you consider me as a contender for the ad to be shown here. Okay, so if this user is coming, so this, if they are telling, okay, I am targeting this 18 to 22, so this user, then this user is coming with, say, this guy and this guy. Say these two advertisers, only two advertisers are there, and they are telling that, okay, this user 18 to 22, I am there. Okay, so now you see, and you don't know who are the users who will be coming next, right? So in this case, you see, if I am at this time, after seeing this user, whenever I am seeing, then I have to decide then and there that whether this user will be allocated to this guy, or this guy. So if the algorithm is there that arbitrarily I'll be choosing any of these, either I can choose this or this. Say I am choosing this. So this is 1, 2, and this user is A. So 1 and A may be matched with my algorithm, right? Okay, so this is as long as we are saying that okay, there are edges available to be matched. I am matching arbitrarily to any of these user. This is the algorithm. So this is one kind of online greedy algorithm. Okay, as long as available, I am matching, right? Okay, so this 1 and A being matched. Now after matching, another user appears. Another user is appearing. Say another user appears. So at that time, say this guy is only targeting this. That he told that say this guy is interested to age group 18 and 22, also 32, 34, maybe something like that. So now if this guy is appearing, then you see this guy is already matched with this guy, so I cannot match this guy with this. This is the assumption we are doing right now. So if in the earlier iteration, if 1 and A being matched, then I am not being able to match this. Say this is B. 1 and B will not be matched. Okay, 1 and B will not be matched, right? So this 1 and B will not be matched, and you will be really annoyed with that. Okay? So this 1 and B will not be matched. 1 and A is matched, but otherwise you see, if in the earlier iteration, if I would have chosen 2 to A, okay, then in this iteration I could have matched this 1 and B. So 2 transactions could be possible. 2 transactions could be possible, but one transaction is possible if I am matching this and this with this. So this is the problem with online algorithm. This is the main challenge. So this is the problem with this online algorithm. And to solve, this is the challenge. Okay, we have to have this challenge. We have to take this challenge on. And you see, if you are now being employed as Google or Microsoft or say Amazon, okay, maybe after 1 or 2 years, if you are very much proficient in algorithms, you might be introduced to this problem, and then you can say, okay, I know already this problem actually, right? So this is, you see, this is one of the modern applications of algorithms. Okay, so this is the greedy. We are telling some kind of greedy approach is we are taking to solve this problem solve this online problem. So that means online problem means all these users, A, B, C, whatever, all these users are coming one by one. That means we don't know who are the users coming up front. Okay, and we have to take at present some irrevocable decision. And many algorithmic problems are online in nature. Okay, so this is some motivations. Okay, so say maybe this, if you will be taught greedy algorithms. Okay, not maybe you will not be taught this algorithm. You will be taught the greedy paradigm, that algorithm design, and then the question might be coming that where I should be using this concept. Okay, greedy algorithm, where I should be using that. Okay, say Sir is teaching us these greedy algorithms, but I am not being able to find out any application of this. But there's a huge applications right now, and most of the algorithm designs are mostly based on this greedy paradigm, which may be giving you some optimal solutions or may not be, right? So whenever we'll be having, so in the previous slide we have got there is one paradigm that we have to have, is this greedy. So there are other paradigms as well. There are other paradigms. So we have to understand each and every paradigm so that whenever new problems are arising, we can solve these problems. Okay, we can solve these problems. So this thing, this online, the problem which I have discussed right now can be used in many different applications. So this is advertisers to users. We can match this, say this side boys, this side girls. Okay, boys and girls could be matched. This side servers, this side some servers. Okay, some servers. Okay, servers, and this side some jobs. Some jobs are appearing online, and we have to match servers with the jobs, and that is very important, say for maybe for cloud computing. Okay, jobs appearing dynamically, jobs appearing, everything right now becoming cloud. Okay, cloud based solutions we are having right now. Okay, so servers to jobs dynamically, when the jobs are arriving, how we can match these jobs to the servers. Okay, so that could be one of the biggest hit in this algorithm design, online algorithm design, and mostly maybe that is based on this greedy paradigm that we will be learning. Okay, so another thing, another interesting say application of these algorithms. So here, even if here I am trying to give you some kind of motivations that why you should be studying algorithm course. Okay, why you should be studying. And okay, I can go back to the previous slide, and one thing is for sure, that one thing is that, okay, you know that this is a very simple algorithm. I have to, whenever somebody is available here and some user appearing, I will be matching that user with the any arbitrary one who are available. Okay, so this is a very simple algorithm, but the thing which is complicated is the analysis. Okay, is the analysis. Okay, so you have designed this algorithm, but how can you analyze? Okay, so there is some analysis techniques, say order of n, and something you have heard of. So this course will be having much more in-depth analysis of this, right? But there are some analysis which is beyond this thing, beyond this order of n, omega n, theta n, whatever. Okay, so beyond that we have to know, and one such analysis is this online. This is we do with this some kind of competitive analysis. So competitive analysis. What is this competitive analysis? The competitive analysis will be thinking that, okay, if some way you know all the users and all the advertiser a priori, say all the advertisers are known to you, all the users who will be coming upfront, you know, and then you will be designing the algorithm. So that we call this offline algorithm. And another thing, we don't know who are the users appearing upfront. Then and there we have to take the decision. So this is the online algorithm. So how much, if I know these two advertisers and these two users, then to come up with this solution will be very much easy. Okay, so then you are having two number of transactions, right? But in this case you are having only one number of transactions, 1 to A matching. So what is the ratio of this one? The online algorithm 1, the offline algorithm 2. So this is half, right? So what is the ratio of online algorithm with the offline one? So this is called this competitive analysis, and this is one of the new inventions that computer science has given to the world. Okay, not mathematics has given to the world. Okay, we are applying this the mathematical concept there, but it is our ingenious discovery, computer science, and as a whole we can be proud of that. Okay, and there are diversified application of this competitive analysis now we are observing in many different fields. Okay, competitive analysis, and this is the creation of computer scientists, mind you, and in 1983 or 1980s, okay, this competitive analysis concept was created by one of the legendary computer scientists called Tarjan. Okay. I don't know how many of you have heard his name. Okay, so I think so. Okay, one thing is that I can open one more document. Maybe this guy. Yes. So before finishing off today, what I can do is I can give you some of the references here. Some of the references. So we'll be using this textbook, Corman textbooks, Corman, Lyserson, Rivest, and Stein, Introduction to Algorithms, and Kleinberg and Tardos. So this Corman book I will be often mentioning as the CLR and S. Okay, CLRS book. CLRS book means Corman book. C for Corman, L for Lyserson, R for Rivest, S for Stein. And this Kleinberg and Tardos book will be often mentioning as KT book. Kleinberg and Tardos. And this Sanjay Dasgupta and Papadomitro and Vajirani algorithms that we may follow, but very little. Okay. And then this Goodrick and Tamasia, that book we can follow. And this and another thing that we'll be following is this Tim Roughgarden's video lectures and notes on CS 161 and CS 261, and NPTEL's lectures on design and analysis of algorithm, NMEICT video on design and algorithms. Okay, so these are some of the references that we'll be having in our book, in our subsequent lectures, but mostly this CLRS will be following. Okay, mostly this CLRS will be following, and then definitely this guy Tim Roughgarden, he is having another book, so that I'll be Algorithms Illuminated. Four books he has published recently, so that you can also follow. That those 4 books are very good. Okay, so these are the references we are giving, and in the next class I'll be discussing some of the remaining motivations of our algorithm design, and then we can start our lectures on this asymptotic analysis. Okay, so if you have any question, you can ask me. I am taking your attendance. Yes.